So you guys are hopefully finished with taking the exam, and we just finished up solving quadratic equations and simplifying and solving radicals, equations with radicals. How was this? Okay, so let me just start that over. So right now you guys are either taking a test or should be taking a test soon, and that was over solving equations and different methods of solving equations. And so we're still in chapter 11, but we're jumping into linear inequalities. So instead of an equation with the equal sign, we're going to have the less than, the greater than, less than or equal to, or greater than or equal to. So solving non-linear inequalities are different than solving linear inequalities. So what am I saying by linear inequalities? That means that the variable x, usually we use x, the exponent is 1. So we don't have a 2 as an exponent, a 3, or a rational 1/2 number. So solving non-linear inequalities, the first step that you want to do is you want to get everything to one side of the inequality. Okay. So first thing you're going to do is get everything to one side. Okay, so it's either less than or equal to, greater than, or greater than or equal to sign. Okay, so once you get everything to one side of the inequality, what we're trying to do is find what are called critical numbers. Critical numbers are values which either set the inequality equal to 0 or values where it's undefined. So values, if it's a rational inequality, that would have variables in the denominator, and then we can't have values which set the denominator equal 0. And so once we get everything to one side of the inequality, we're going to find our critical numbers. Sometimes they're called critical values, and I probably will interchange those two words over and over again. So finding the critical numbers, again, you're going to do this by finding the values which make it equal to 0. And you're also going to find where it's undefined. So values where the inequality is undefined. Okay, so once you found those values, I think the easiest way is just to place them on a number line that kind of keeps track of what things are doing. So we're going to place the numbers on a number line. Okay, so once we place those numbers on the number line, we're going to have different intervals split up by the different numbers that we just found. And so what we want to do is we want to test the interval to see if we plug a number inside that interval, and we just have to choose one of those numbers inside that interval. If we plug it back into the inequality and it gives me a true statement, then that is true, and that whole entire interval is part of the solution. If I plug in a number in that interval and it's a false statement back into the inequality, then I would say that any number that fell in that interval between those two critical numbers is not a solution. Okay, so let me just kind of abbreviate that in our notes here. So after you place the numbers on the number line, you're going to choose one number inside each interval and plug it back into the inequality to see if it's true or false. Okay, so once we've checked all the different intervals and we see which parts are true and which parts are false, then we know what our solution is. There's one other thing that we have to worry about, and that is what's happening on those critical values. Well, if it's undefined, we're not going to have it. As part of our solution, we would put a parentheses there if we're looking at the number line or an open circle. But if we have a critical number that is defined and our inequality has the equal to part to it, then we want to include those critical numbers. If you do not have the equal part on the inequality, then we do not want to include the critical numbers. So you're going to determine are the critical numbers part of the solution. Oops. Okay, so let's look at an example. So what about x squared minus 4x plus 3 is greater than or equal to 0? Okay, so first step was to get everything to one side of the inequality. It's already done. The second step is to find the critical numbers, and that is setting that equal to 0 and finding when it is equal to 0. So find critical numbers. So we're looking at when is x squared minus 4x plus 3 equal to 0? Okay, well, we were just solving these. So quadratic equations, if you can factor it, usually that's the fastest and easiest way to go. And I can see that there are two numbers that multiply to give you 3 and add to give you a -4. So we can factor this as x minus 3 all times x minus 1 is equal to 0. So x minus 3 is equal to 0 when x is 3. And x minus 1 is equal to 0 when x is 1. Okay, so we're going to place these numbers on the number line. And so smallest to largest. So we have the number 1 and we have 3. Okay, so looking at this, I can tell I have 3 separate intervals. So I have one to the left of 1, I have one in between 1 and 3, and I have one that is greater than 3. So when you're choosing a number, you do not want to choose your critical number. We already know those are the values which set it equal to 0. So we want to choose a number to the left of 1. If 0 is not part of your critical number and it falls into that set, it's usually the easiest one to plug in. And so if we plug in 0 for x, we get 0 squared minus 4 times 0 plus 3, is this greater than or equal to 0? And so noticing that and simplifying, you can see that 3 is greater than or equal to 0, and this is a true statement. So now you want to choose a number that falls in between 1 and 3. So how about 2? So if we plug that back into the original inequality, we have 2 squared minus 4 times, we chose x to be 2, 2 plus 3. And we're asking ourselves, is that greater than or equal to 0? And so 2 squared is 4. 4 times 2 is 8, so minus 8 plus 3. So 4 minus 8, that's a negative 4. Negative 4 plus 3 gives us negative 1. Well, negative 1 is not bigger than 0, and so that's false, and this interval would be false. So any number in between 1 and 3 would not work if we plugged it back into that inequality. And so we need to choose one other number on the right of 3. So what about x equals 4? So plugging it into the inequality, we get 4 squared minus 4 times x, which is 4, plus 3. We are checking to see, is that greater than or equal to 0? Sorry, I ran out of room. So I get 16 minus 16 plus 3. And so 3 is greater than or equal to 0, which is true. Okay, so on this, I can see that if they were asking you to graph the solution, I know anything to the left of 1 would work, and that's part of my solution. And I know everything to the right of 3, that's part of my solution. So once we figure out what the solution is, then we're going to want to look at, are we going to include 1 and 3 as part of our solution? So again, those were our critical numbers. Our critical numbers are defined at 1 and 3. And if we plug those in, those were the values what set it equal to 0. So you're asking yourself, is 0 really greater than or equal to 0? Yeah, it is equal to. So it is part of our solution. And so we're going to include 1 as part of our solution, and we're going to include 3 as part of our solution. So homework, and it's good to be able to get into the habit of writing things in interval notation. You'll see that over and over and do that a lot in math. So they might ask you to write your solution in interval notation. Well, since we just graphed that, it's pretty much in interval notation. All right, let's see if I can move down. So looking at the shaded area, I'm coming in always left to right, smallest to largest, never include negative infinity or infinity on the inequality. And so we have parentheses, negative infinity to 1. It's included, so we use a bracket, union, and then 3, and including 3, so we use a bracket to infinity, parentheses. Okay. So I kind of want to just show you what's going on here. In a minute or later on today, we're going to start graphing quadratic equations. And you might be familiar that graphing a quadratic equation, you're going to get a graph of a parabola, so either facing up or facing down. Let's look at, let me pull it up real quick, the graph of what we just did, if that was the equation. I just lost my screen. Okay, so we just had the inequality. It was x squared minus 4x plus 3. So looking at this graph, and we were looking at when is this greater than or equal to 0? So we're looking at when are our y values bigger than or equal to 0? And so we're looking actually at this graph, when is it falling above the x-axis? And so notice that where it's crossing the x-axis here is at 1, and where it's crossing the x-axis here is at 3. Any number in between 1 and 3 are giving us y values that are negative and are falling below the x-axis. But any number that is the left of 1 is above the x-axis, which are giving us back positive numbers if you plug them in for x. And to the right, you're also getting back positive numbers. So technically what you're doing is when you're looking at these inequalities, you're seeing if you plugged in numbers, would that graph, if we graphed it, fall above or below the x-axis? I'm wondering if I can put that in there right here. No, I didn't like that. Okay. So hopefully that that helps a little bit. So let's look at another example. Okay. So this time we have 16x cubed plus 48x squared minus 25x is less than 75. Okay, so first step, get everything to one side of the inequality. And so we need to move that 75 over to the other side. So if we subtract 75 on both sides, we get 16x cubed plus 48x squared minus 25x minus 75 is less than 0. So find your critical numbers. And so those are the values which either set it equal to 0 or where it's undefined. Only time that they're going to be undefined are when we have variables in the denominator in these cases. If it's a polynomial like this where you don't have variables in your denominator, then you don't have to worry about it being undefined anywhere. Okay, so anyways, notice that, okay, when I'm doing this, I know I have to factor it. And remember, first thing that you do when you're factoring is you pull out the greatest common factor if possible. Well, this has 4 terms, and I don't see anything in common with those 4 terms. So remember, the number of terms also helps us to determine how we're going to go about to factor. And so noticing that this is 4 terms, then look at it and see if you can do factoring by grouping, which I notice we can. And so looking at 16x cubed plus 48x squared, they both have a 16 in common and an x squared in common. So I'm going to pull 16x squared out of the first 2 terms, and that would just leave me with a single x for the first term plus, well, 3 times 16 is 48, so plus 3. So now looking at the last 2 terms on that left-hand side of the equation, I want to pull out what they have in common. And so I notice in here, they both have a negative 25 in common. So I'm going to pull out a negative 25 from both of those terms. And then we're going to be left with positive x plus 3. And we're trying to find when this is equal to 0. So everything turned out just like I wanted. I can do factoring by grouping because what's inside the parentheses is the same, x plus 3. So we can pull that out, leaving us with 16x squared minus 25 is equal to 0. So I can go and set each piece equal to 0 and then use the square root method for the middle piece. Or I notice that that factors There's a difference of squares there, so I can think of it that way too. I'm just going to factor it. So we have x plus 3, difference of squares. So this would give me 4x minus 5, all times 4x plus 5. So looking at when is x plus 3 equal to 0, that's x is negative 3, subtracting 3 on both sides. 4x minus 5 is equal to 0. You're going to get x by itself, so add 5 and then divide by 4. We get x is 5/4. We're looking at when is 4x plus 5 equal to 0. Subtract 5 and then divide by 4. We get x is negative 5/4. Okay, so those are just the critical numbers, which are going to help me determine if it's true or false on the left and the right of my inequality of these critical numbers. Okay, so smallest to largest of my critical numbers, I have a negative 3. This is my smallest critical number, negative 5/4, which is negative 1 1/4. And we have 5/4. So looking at this, I have 1, 2, 3, 4 different intervals where I'm going to have to choose a number that falls in that interval, plug it into the inequality to see if it's true or false. So a couple things that might be helpful here. We really don't care what the number is that we plug in, what the value is. We just care, is it positive or negative, and does it make a true or a false statement? And so sometimes it's just useful to use if I'm multiplying 2 positive together, is it going to be positive? Yeah. Or if I'm dividing 2 negatives, it's positive. So just thinking about it logically that way, you can determine if that interval is going to be true or false. So for instance, we just factored this, right? And so we could technically be plugging in our values into x plus 3, 4x minus 5, all times 4x plus 5. And we were looking at when is this less than 0? So it's just a factored form of our original inequality with everything to one side. So let's plug in a number less than negative 3. And so smaller usually is better. So let's look at x equals negative 4. So let's look at the first parentheses. If you plug in negative 4 into that first parentheses, determine is it going to be positive or negative. Well, negative 4 plus 3, I know that that is negative 1, so that's a negative. If I plug in negative 4 into 4x minus 5, I notice I get a negative number minus a number, which is negative. And then if I plug in negative 4 into the third parentheses, 4 times negative 4 is negative 16 plus 5. I also know that's negative. If you multiply 3 negatives together, is that truly less than 0? And it is. No, yes, right? So negative times a negative is a positive, and a positive times a negative is a negative. So this is a true statement. So now choose a number between negative 3 and negative 1 1/4. And so what about x equal negative 2? So again, think about it, plugging it into the parentheses, and if you really want to figure out what that number is, you can, but I'm just really curious, is it positive or negative? So negative 2 plus 3, I know is a positive number, so I'm going to take a positive number times negative 2 times 4, that's negative 8 minus 5 is a negative number. And then negative 2 times 4, that's negative 8 plus 5 is also a negative number. So multiplying this across, a positive times a negative is negative, and then a negative times a negative is positive. And we were checking to see, is that number smaller than 0? Well, positive is not smaller than 0, so this is false. Okay, so choosing a number between -1/4 and 5/4. So what about x equals, well, 0 falls in between that interval. So if I plug it in, I get back just the constants left in each one of those parentheses. So 3 is positive. 0 minus 5, so -5 is negative. Positive 5, so that's positive. Is this strictly less than 0? Well, positive times a negative is negative, and a negative times a positive is negative. So this gives us a negative number. Is a negative number less than 0? That's true. Okay, one more. Choose a number that's bigger than 5/4. And so let's look at x equals 2. So 2 plus 3, that first parentheses is positive. 4 times 2 is 8 minus 5, that's a positive number. 4 times 2 plus 5 is also positive. If you multiply 3 positives together, would that give us something less than 0? And that's false. Okay, so I can see here that anything to the left of -3 is part of my solution. I can see anything that falls in between -5/4 and -5/4 and 5/4 is also a solution. So once you've determined which intervals work, then you determine, do you include those inequalities? Well, going back to our inequality, it was a strictly less than. It did not have the equal sign with it. These critical values set everything equal to 0, and 0 is not strictly less than 0. So I know that those are not part of my solution. And so I'm going to have a parentheses on the -3, and I'm going to have a parentheses surrounding the -5/4 and the 5/4. And so our solution sorry. Okay. Our solution, looking at this, is coming from -infinity all the way to -3, not including, so a parentheses, union, which means we're taking plus this other set, -5/4 to 5/4. And those inbounds also have parentheses. Okay, so let's now look at one other type that you'll see in this section, which are rational inequalities. So the only difference with rational inequalities is that you're looking at when the denominator is equal to 0, because those are values where it is undefined. We can't have divide by 0. So let's say we had the following. Let's just start it out where it's already factored for us. So let's say you had in parentheses x plus 5, all times in parentheses x minus 5, all over x. And we're looking at when this is less than 0. And again, we want to find our critical numbers. So just like we had done before, these are values which make it equal to 0, but it's also values where it's undefined. So this is where students a lot of times will make errors. They will try to clear the fraction here. And so if you're clearing the fraction, you're not getting one of those critical numbers, the number that sets it equal to 0 in the denominator. And so you got to be careful about that and doing that. So if you do that, it will work, but you need to include that number originally, which set the denominator equal 0. So I tend not to do it that way. I tend to get everything to one side of my inequality when I'm dealing with rational inequalities, get it as one fraction, and then I look at when is my numerator equal to 0, because that would set the whole thing equal to 0, and when is my denominator equal to 0, because that's where it's undefined. So again, critical numbers, we're looking at when is x plus 5 all times x minus 5, in this case, all over x equal to 0, and undefined. Okay, so now that it is an equal sign, I can think of it as it's an equation, I can clear my fraction by multiplying both sides by x. And so doing that, right, and the whole point was so my fraction would go away. That's going to clear my fraction, and I'm going to be left with the x plus 5 times the x minus 5 equal to 0. And so setting each factor equal to 0, I can see that that's when x is negative 5 and when x is positive 5. And I can also see that it's undefined when the denominator equals 0. And so x is equal to 0, well, basically that's your answer, right? So we have three critical numbers here. And so again, you're going to place them on the number line. Smallest to largest. So negative 5, 0, and 5. And we're going to go back and we're going to plug it into our inequality and see if it's a true or false statement. So again, looking at how many intervals I have to look at. I have one on here, 2, 3. There's 4 separate intervals I'm going to have to check. It will be helpful if I had this to the side. So x plus 5, x minus 5, all over x. We're looking at when is this less than 0. So if we choose a number to the left of negative 5, so negative 6 works. Again, let's think about positive and negative. So negative 6 plus 5, that's a negative number. Negative 6 minus 11, that's also negative. All over x is negative 6, so that's negative. And we're asking ourselves, would that number be smaller than 0? Well, negative times negative is positive. Is a positive divided by a negative negative? And it is. So this is true. So now we want to choose a number between negative 5 and 5. So how about 4? So if we plug in 4 into the first parentheses, that's a positive. 4 minus 5, that's a negative. And x is positive, so the denominator is positive. And we want to know, is this less than 0? Well, I get a negative in my numerator and a positive in my denominator. Actually, I made a mistake there, guys. I was looking at x equals 4. So actually, I'm just going to move this over. I wasn't doing it between negative 5 and 0. Oops. So we can just continue. So that would give me a number that was less than 0. Oops. Of course, things never work out on it. And so that was, we determined was a true statement, right? This was also true. Now choose a number between negative 5 and 0. I skipped that interval. So now if we had done that, how about negative 4? So plugging in negative 4, we get negative 4 plus 5 is positive. Negative 4 minus 5 is negative. and -4 in the denominator is negative. So positive times a negative is a negative, and all over a negative. So negative over a negative is actually a positive, and a positive is not smaller than 0, so this is false. And then one more number. So how about 6 to the left of 5? So if we plug in 6 to x plus 5, that's positive. 6 minus 5 is also positive. All over 6, which is a positive number, is that smaller than 0? So that's false. So looking at this, we have a solution, everything to the left of -5 and everything in between and including 5. So now we need to determine, do we include those intervals or not? Well, because this is strictly less than 0, I don't have to worry about it. I can just not include any here. So there would be parentheses. If that had the equal to part in it, you need to be careful because you would not include the value which set the denominator equal to 0, but you would include the numbers that set the numerator equal to 0. So we have our solution, -infinity to -5, parentheses, union 0 to 5, and those are both in parentheses. Okay, so that concludes, actually, I guess I could do one more problem. Let's do one more problem with a rational, and that would be what 11.4 is. Let's see. So what about 6x all divided by 5 minus x is greater than or equal to 3x? Okay, so again, we want to get everything to one side of the inequality. If we try to clear our fraction, we are going to be losing one of our critical numbers here. And so we want to get this greater than or equal to 0. So I notice that I can subtract 3x on both sides of my equal sign. And so doing that, we get 6x all over 5 minus x minus 3x is greater than or equal to 0. I'm leaving a little bit of room there because I noticed that in order to combine this as one fraction, I'm going to need a common denominator. So get everything to one side. The inequality. And combine it to be one fraction. Okay, so looking at this, my least common denominator is just 5 minus x. So my LCD, I notice, is 5 minus x. So I'm just going to multiply this negative 3x by a fancy way to write 1, which doesn't alter the solution. Okay, so be careful. You want to carry the sign when you distribute the 3x. So we're going to distribute negative 3x. I'm just going to bring down the 6x. Now that I have a common denominator, 5 minus x, I'm just going to rewrite this as one fraction. And so now distributing my negative 3x, I got negative 3x times 5, that's negative 15x. And negative 3x times negative x is positive 3x squared. So looking at that, I would rewrite my numerator. I notice it's a quadratic equation, and then I would try to factor it. If not, I would set that, use probably the quadratic formula to find out when that's 0, if it is. So rewriting this, I have 3x squared minus 15x. Oops, actually, sorry guys. I notice that I can combine like terms, right? I have a 6x minus a 15x. So that's actually a negative 9x. So I don't have to go through and use my quadratic formula or anything. I can factor that, right? They both have a 3x in common in my numerator. So we can pull the 3x out. And that would leave you with an x minus 3 all over 5 minus x. Okay, so critical numbers. We're looking at when is 3x all times x minus 3 all over 5 minus x equal to 0, and undefined. Okay, so let's do undefined first. That's when our denominator equals 0. So 5 minus x equal to 0. Well, if you add x on both sides, this is when x is equal to 5. And then if you look at the rational equation, if you multiply both sides by the denominator, you're basically just looking at when is that numerator equal to 0. So when is 3x all times x minus 3 equal to 0? Well, that's when 3x is equal to 0. So that's when x is 0, and that's when x minus 3 equals 0. So that's when x is 3. So we have 3 critical numbers, 2 of it which are defined for a function, 1 of which is not. We want to plug this in, or not plug this in, draw our number line, and then start plugging numbers in. So our smallest number was 0, then we had 3, and then we had 5. I'm going to do the same thing as just trying to figure out, is it positive or negative result with the number I plug in, and would that make that statement inequality a true or a false statement? And so if I choose a number less than 0, so how about x equals negative 1? So 3 times negative 1 is a negative number. Negative 1 minus 3 is also a negative number, all over 5 minus negative 1. So that's really 5 plus 1. I know that's positive. Is that greater than or equal to 0? Well, negative times negative is positive. Positive divided by positive is positive, and a positive number is greater than 0. So this is true. Choose a number that falls in between 0 and 3. So if we chose x equals 1, well, 3 times 1, that's a positive number. 1 minus 3, that's a negative number, all over 5 minus 1, which is a positive. So I have a negative divided by a positive. A negative divided by a positive is a negative number. And so this is false. Choose a number that is between 3 and 5. So how about x equals 4? So I have 3 times 4 is positive. I have 4 minus 3 is positive. And 5 minus 4 is positive. So multiplying everything that's positive, dividing by a positive is bigger than or equal to 0. And so this is true. One more. Let's look at x equals 6. So 3 times 6 is positive. 6 minus 3 is positive. All divided by 5 minus 6. Well, I'm subtracting off a bigger number, so that's negative. Is this bigger than or equal to 0? And this is false.
Okay, so again, I know what my solutions are, which part of the interval makes this true. And so anything to the left of 0 and anything between 3 and 5 work. And so I want to look at what values make this equal to 0, but where it's defined. So I noticed that values which set it equal to 0 are 0 and 3. And so that would give me a true statement. 0 is greater than or equal to 0. It's equal. So we're going to include 0 as part of our solution. So I need a bracket. And I'm going to include 3 as part of my solution. So I'm going to have the bracket on the left here. The thing is 5 is undefined. That sets the denominator equals 0. So that means that it's not part of my domain. And so I need a parentheses. And so looking at this, we're going to do our solution. We're coming from negative infinity to 0 with a bracket. Union, you're going bracket 3 to 5 parentheses. Okay, I didn't mean to do that. Let me pause recording. Okay, so we just finished looking at non-linear inequalities and solving those non-linear inequalities. And now we're jumping into graphing quadratic equations. So 11.5 starts you off with graphing quadratic equations in certain form, and then 11.6 will look further into graphing quadratic equations and trying to get it into this form that we are going to look at in this section. So a quadratic equation can be written in the form
Am I supposed to be able to see your screen right now?
You are. So let me share my screen.
Okay, cool.
Thank you.
Mhm.
I can find it. Okay, so this. Okay, so quadratic equation can be written in the following form. It's not always in this form, but it can be written in this form. And when it's written in this form, it really tells us a lot about the graph and what it looks like. So it can be written in the form y equals a parentheses x minus h, end of your parentheses, quantity squared plus k. So this is our vertex form. So the value of a, the number that is in front of that x minus h quantity squared, tells us what direction our parabola faces. It's either going to go up or it's going to go down. And so if the number in front of this x minus h quantity squared is positive, then your parabola faces up. If the number in front of that quantity squared is negative, so we know that the parabola faces downwards. In here, we can tell what the vertex is. And the vertex is the value or the point where your parabola is changing direction. So if it's facing up, you're going to have the vertexes at the point where it's changing from decreasing to increasing. If the parabola is facing down, the vertex is where it's changing from increasing to decreasing. And the vertex is always going to be at the value HK. And so just to be aware, notice this H here, this is the opposite sign. Okay, so it's going to be the opposite sign of what you see in here. So if this is x minus 3, the h value is 3. If this is x plus 3, then the h value would be negative 3. The k value, though, is the same. Same sign. Okay, so the vertexes are an important point on our parabola. It's where it's changing direction, but it's also looking at it, you can tell it's either going to be a maximum point or a minimum point on the graph. And so if A is bigger than 0, then your vertex is going to be a minimum value. And if your A value is less than 0, then your vertex is a max. Okay, so for instance, let's just say that you had y is equal to 2 all times x minus 3 quantity squared minus 8. So part A, what is the vertex? Okay, so again, it's opposite sign of what's inside the parentheses is the x value of the vertex. And so since this is a minus 3, we would have positive 3. And then it's the same sign outside, so this would be minus 8. So the vertex is going to occur at the point 3, negative 8 on the graph. And so we then want to determine, is that vertex a max or a min y? Oops. So you need to look at the number in front of the quantity square. And so our A value in this case is equal to 2. And this is greater than 0. So this tells me that the parabola faces upwards. And so because of that, I can tell that this is a minimum point. So let's find the X-intercept, if they exist. Okay, so remember when you're looking at a graph and the places where it's crossing the x-axis or touching the x-axis are your x-intercepts. So on the x-axis, your y value is always 0. And so to find your x-intercept, you're going to let y equal 0 and solve for x. And so if we do that, we have the equation where we have 0 now is equal to a, which was 2, all times x minus 3 quantity squared, and I think I did minus 8. So we want to solve for x here. And so we just looked at all these different tools of how we could solve quadratic equations. And so before, we would have had to expand this out and would have had to try to factor it if possible. But because of the beginning of chapter 11, we can now notice we can use the quadratic, we can use the square root method because we have a perfect square in here. And so let's add 8 to both sides of our equation. And so we would get 8 is equal to 2 times x minus 3 quantity squared. I want to isolate the square so I can take the square root. And so let's divide both sides of this by 2. So we get 4 is equal to x minus 3 quantity squared. So taking the square root of both sides, we have to do the plus or minus the square root of 4. This is equal to the square root of x minus 3 quantity squared. So plus or minus square root of 4, well, that's plus or minus 2, is equal to, the whole point of doing the square root method was to get rid of that square, is x minus 3. So I have 2 separate equations. I'm going to write it out because 2 equations because I know I can combine like terms. So I have x minus 3 equals positive 2, and I have x minus 3 is equal to negative 2. So get x by itself. If you add 3 to both sides, we get x is equal to 5. Add 3 to both sides here, x is equal to negative 2 plus 3, so that's 1. Okay, so we found our x-intercepts. One more thing to find. Let's find the y-intercept. Okay, so the y-intercept occurs when the point is crossing or touching the y-axis on the graph. And whenever you're on the y-intercept, your x value is 0. And so to find the y-intercept, you always let x equal 0 and solve for y. And so in our equation, we had y is equal to 2 all times, parentheses, x, which is 0 in our case, minus 3, quantity squared, minus 8. So I just want to reduce this and simplify. So order of operations work inside our parentheses first before we do multiplication. So this is 2 times, well, negative 3 quantity squared. Negative 3 times negative 3 is positive 9 minus 8. So y is equal to, multiplication comes before subtraction. So y is equal to 18 minus 8, or y is equal to 10. So pretty much because of what we found so far, it shouldn't be hard to graph at all. Okay, Okay, so we're gonna plot our points. Let me just go back and see what my vertex was. I should know that, 3 minus 8. So I had a point when X was 3, Y was -8. And then we found that the graph was crossing this x-axis when X was 1 and when X was 5. And now we just found that it's crossing the y-axis when X was y-axis when Y was 10. And so I know that the graphs of quadratics are parabola shapes, and I can see the shape that this is going to look like. And we know what the minimum point is. And so in the past, that has been our problem, is that we didn't know where it changed directions when we were graphing this. We could graph it by plotting points, but now we can figure out where our vertex is by that vertex formula and graph it pretty easily. So I want you to kind of be aware of a couple of things. So looking at this graph, notice that if you folded your paper along this line, this vertical line, X equals 3, that graph should lie on top of each other. So if this was a paper and we folded it here, that would be, it's called symmetrical. So notice that this graph is symmetrical. Across a line. Vertical lines are always in the form of X equals the number, so X equals 3. Okay, so this section, all of these equations are going to be in that form, that vertex form. And so the process of graphing these, first thing that you want to do, or I guess a couple of these items, doesn't matter order, but you want to find the vertex. If possible, find the X-Intercept. It's not always possible. A graph might not cross the X-axis. In our case, because our graphs always face up and down, later in courses, they could go left or right. But in our case, up and down, it's always going to cross the y-axis once. So you'll always have a y-intercept, but it's possible you don't have an x-intercept. So let me just kind of show you, the different possibilities that could happen when you're graphing these. And this is where, when we were looking at the discriminant, when we were looking at the quadratic formula and we were looking at that b squared minus 4ac, was that number positive or was that number negative? And that told us how many solutions we had and what type. So this is where that discriminant could be helpful, because if that discriminant is negative, then you're going to get an imaginary number as your solution, which means it does not cross the axis. If you get that it's equal to 0, that means I only have one solution. So actually that's telling me the vertex is touching the x-axis. And if I get a positive number, I have two real solutions, which tells me that the graph is crossing the x-axis twice. Okay, so again, in vertex form is y equals a, all times x minus h, quantity squared plus k. Again, the vertex, opposite sign inside the parentheses, so positive h, same sign outside, k. So notice if, let's say that you had a problem with fix this. So notice this does not cross the x-axis. So if I didn't realize that, so another thing that's helpful is find out where the vertex is. And then if you can tell, is the parabola going up or down? Because where the vertex is and the direction the parabola faces, you can tell if it's going to cross that axis or not. So it does not cross the x-axis. If you were to solve for the x-intercept, so if you hadn't noticed that and you were trying to find the x-intercept, you let y equal 0, what's going to happen is your solution is going to be a complex number. So if you solve for the x-intercept, you will get 2 complex numbers. So they're not real numbers. So if we had, how about y is equal to 2 all times x plus 1 quantity squared minus 1. So looking at this, what's the vertex? So opposite sign inside the parentheses. So -1, same sign outside of the parentheses, -1. Determine, is the parabola going up or down? So A in our case is 2. It's a positive number. So it's happy. It faces up. And so I can tell that this is what my parabola is going to look like. So now if I just determine, where's that point, -1, -1? So if I plotted that point, -1, -1, and I know that this parabola goes upwards, right? That tells me I better get a solution. Actually, I'm going to get 2 solutions when I try to solve for the x-intercept. So okay. So I could go through and I could solve for that. And I would set my y value equal to 0. Maybe we should just do that. So let's find then the x-intercepts. Okay, so set our equation equal to 0. So we had 0 is equal to, what was it, 2 all times x plus 1 quantity squared minus 1. So a couple of things I can do. Again, I can expand this out, x plus 1 times x plus 1, and then try to factor it, or use the quadratic formula. But because I don't have any x's outside of this quantity square, I can use the square root method. So let's add 1 to both sides and divide by 2. So adding 1 to both sides, we get 1 is equal to 2 times the quantity x plus 1 quantity squared. Divide by 2 on both sides. So we get 1/2 is equal to x plus 1 quantity squared. I need to take the square root of both sides to get rid of the square. So plus or minus the square root of 1/2 is equal to the square root of x plus 1 quantity squared. So I get plus or minus the square root of 1/2 equals x plus 1. So I just need to subtract 1 on both sides to get x by itself. And so I'm just going to do here. We're going to get x is equal to -1 plus or minus. So remember, the square root of a fraction, I'm going to break that down. That's the square root of the numerator all over the square root of the denominator. So square root of 1 is 1 all over the square root of 2. Well, there's no whole number that would work. A lot of times in math, you don't like radicals in the denominator, and just as practice, because that's what we were just covering, let's rationalize that denominator. And so we can get that square root of 2 out of the denominator by multiplying by that fancy 1. Okay, so to get rid of the radical, we need 2 2's under there for this case, so we need 1 more 2. We're going to multiply the numerator and denominator by 2. And so we get x is equal to -1 plus or minus root 2 all over 2. Let's combine it as one fraction, just to get some practice. So I notice my LCD is 2. I can multiply that -1 by 2 over 2. So I get x is equal to -2 plus or minus root 2 all over our LCD of 2. Okay, the thing is, I got to graph this. And when I look at the number -2 plus root 2 over 2, or -2 minus root 2 over 2, I have no clue what that is. I could probably estimate, but it would be nice if your teacher let you use a calculator and we could figure out approximately what that is. So she would. -2 plus the square root of 2, and I'm going to put that all in parentheses because that's my numerator. And then I'm going to divide that by 2. And so I get approximately -0.3. So this gives me two values, -0.3. And then if I did -2 minus instead of plus root 2, all divided by 2, we get approximately -1.7. Okay, so X-intercept, we got that. Now if we got the Y-intercept, we already, then we can pretty much graph it because we have the vertex. So Y-intercept. Well, x equals 0. And so we get 0 is equal to 2 all times. You see an x there, put in 0. It was plus 1. Quantity squared minus 1. So if 0 is 2 times 1 minus 1. And I made a mistake there because I said, let's plug in 0 for x, and I plugged in 0 for y also. So let me change that. That should be y equals, not 0 equals. So y equals 2 times 1, which is 2. 2 minus 1 is 1. Okay, so we're going to graph this. We saw that we had a point at -1, -1, and that was our vertex. We saw that we had a y-intercept at +1. And then we got our two x-intercepts. One was -0.3, so just estimate it. And one was about -1.7. And so we can now draw our parabola. Oops. I don't like my parabola. And then one more thing, if we were to look at the axis of symmetry, so that's always the line that you can fold your paper on. Notice that it's always that line that's going through the vertex. In this case is x equals -1 is the axis of symmetry. So this is always the x value of the vertex. If we're looking at parabolas going up or down, left or right is different. So always the x value of the vertex. So technically you see it with a dotted line there, but it's really not part of the graph. It's just showing you that that's where it's symmetrical. So I might ask you something like the following. I might say, what is the point that's symmetrical to the point on the y-axis? You'll notice that everything is a certain distance. So the same distance it takes me to get from this side of the parabola to the vertex is the same distance as it would take me to get here. And so if I know this distance from x equals -1 to x equals 0, that's a distance of 1. So I would have to go over a distance of 1 in the other direction to get that point that's symmetrical. And so if I go over a distance of 1 from -1 to the left, well, -1 minus a 1, that's -2. And so I can tell that my point -2, x is -2, the y value here is same as the y value of your intercept, 1 is the point symmetrical to the y-intercept. Let me just see. Okay, so we pretty much did everything from this section. Basically, you're going to be always given in vertex form. Next section, next week, look forward to using completing the square again so that we can get things into that vertex form. Because notice that vertex form up here, let me find it again. Notice that you have some quantity square here. And that's what we were doing when we were trying to complete the square to get our equation in that perfect square.
And so if our equation is not like this, where we have that parentheses x minus h quantity squared plus that constant, then we can manipulate it to be that way by completing the square. So if completing the square was something difficult for you, you might want to review that before we lecture on Monday. So homework for this week is 11.4 and 11.5.
Also, for the lecture notes for the 6th, are we not turning those in?
So lecture notes, I just haven't gotten to the point of uploading the assignment.
Okay.
I will put that up. I'll have it just due probably Monday next week. But if it's late, I'm not going to dock it.
Okay.
I think I'm going to just start putting it up, do once a week. That way you don't have to scan it or take pictures twice and upload it. And it's once versus.
So can we turn in whatever of the lecture notes we have from the 6th, or should we wait until we write?
Wait till you do all of them. I don't even have the assignment up for you to post the 6th lecture notes anyways. So I'll have that up hopefully by the end of the day. But it won't be due until Monday next week. Let me pause the